Hello everyone, and welcome to another session here in DevOps classes. Today we are going to look into the second part of Bash scripting. In previous class we have seen how to work with the variables, conditional statements, defining functions, uh, trapping the Bash commands, and all the routine kind of things. We have also seen the loops. Today we are going to look into what expressions are, how to use the comparison operators, what are the different arithmetic operators which are available here, the case statements, the selector statements, returning values from functions, and file descriptors. So let's talk of it. But first I need my machine to be up, and while I do so, if you have any queries or doubts from the previous sessions, feel free to ask them. Alright, so my machine is up. I'm logging into that, and let me get the IP address so that I could connect to it using my external client, which is Putty. So we are all set, and let's continue where we have left off. So yesterday I've also shown you how to run that script in 3-4 different ways, right? By absolute path, by relative path, by using bash command, and by placing that into path so that we could use our script itself as a command on this CLI front. Okay, our example file, right? So let's see what comparison operators are available here and how do we use it. So for arithmetic comparisons, so there are two different kinds of comparisons, string comparisons and arithmetic comparisons. For arithmetic comparisons or anything that is related to numbers, we would be comparing them like this. We have got multiple operators, so less than, greater than, less than equals to, greater than equals to, it is equals to and not equals to. Everyone is aware of these operators, right? But here in Bash, since these operators would be used for redirection purposes, we'll see how redirection would work. In the while loop, we have redirected from standard input using the less than arrow. So it was something like this. While expression do done, and after done we have written $1, if you remember that, right? So that's redirecting from standard input. So that's the reason why we don't overlap these operators, and we are going to have some special characters that denote what the meaning is. So less than is written minus LT. I've used a few of them in my expressions already. Greater than is called minus GT. Very easy to remember, greater than, so it is GT, less than L and T. Then less than equals to, so you would be writing LE, less than and equals to. For greater than and equals to, we would be writing GE. Remember that the minus sign is important, it's mandatory. Equals to is EQ, and not equals to, as expected, would be not equals to and E. Okay, so if you want to check whether number 1 is equals to number 2, like I already did, we wrote something like this: number 1 EQ number 2. Okay, so this is the meaning of the previous expressions that we have seen yesterday. For strings, they're going to be a little bit different. So these operators here are for numeric comparison. So this is for numeric comparison. Another one is for string comparison. So you need to be very sure what you're comparing there. In string comparisons, again, you have got less than, greater than, less than equals to, greater than equals to, not equals to. Okay, so for string comparison, we don't have less than equals to and greater than equals to. For less than, we use less than. For greater than, we use greater than. Nothing fancy. For equals to, we use equals to. For not equals to, we use not equals to. Nothing changes. Okay, the changes for equals to, it is just single equals to sign with spaces on either side of it. If there is no space, it would be considered as an assignment operator, which we don't want. Then with strings, we also have minus n. Okay, the format would be -1 and your string, and then there is another one -z and your string. So this means that S1 is not empty. It checks whether the S1 is not empty. And the other one -z would check that S1 is empty. So if you write something like this, if square brackets -z S1, of course $S1, and then you write echo if S1 is empty, in that case write empty string. Okay, and reverse phi to end that if statement. So this would work if string is empty. If you want to run it when string is not empty, you'll have to change -z to -n. So they are just complementary to one another. Now with the files, since this is very strong language for file operation, it also contains a few operators, actually a list of operators using which you could check various file states. I will not go through all of them, just the basics. So we would be looking at some file operators. Okay, so if you want to check whether the file is a regular file, okay, so we write like this -f, and of course after every operator there is going to be a file name. Either you hard code a file name or you use it from the variable, anything works. So file operators is -f for, I would be writing the meanings for regular file. -d should be for directory, so whether the text that you are writing after -d is a directory or not. Okay, so if you want to check for whether the file exists, it is for file exist, returns true or false. Then if you want to check whether it is a link, that means a shortcut. Okay, and there are many more. A few ones that you would be looking for is -x, whether it is executable. Only in that case you try to execute it, and so on. Okay, so these ones are generally used for general purposes. Okay, one more which is generally used is -r to check whether the file is readable. And if you guessed it right, it is -w for writable. This is when you check whether the file is readable, writable, or executable and perform the similar actions on it. Okay, so very simple example for file exists would be like this, that if -e and then the file name, whatever the file name is. Now mind the spaces, right, on either sides here. Then you would say echo file exist. Okay, else echo file does not exist, and reverse if. So it is 5. Okay, so there could be conditions where or cases where you want to create a daemon, and that daemon would sleep till the file does not exist. Okay, so there might be cases. So when do we need it? You want to log something. You're trying to log the data to a file, but the file does not exist, and the creation of that file is not in your hand. You're waiting for that file to appear first, and then read from it or write from it. So the condition would be like this: if now minus e, what is opposite of minus e? So if this is my file, okay, whatever the file is, and then do ends with done, we'll say sleep for 1 second. So this sleeps till the file exists, but I want to do till the file does not exist. So I'll simply add an exclamation sign before it. So it is negative minus e. Minus e checks for the file existence, negative minus e would be checking for file does not exist. So till the file does not exist, we will keep that daemon in a sleep state, and once that reappears or file appears there, we would be reading from the file or adding to the file, whatever the case is. So here we have used exclamation sign to reverse the effect of minus e. Okay, so since we have seen the loops already, I'll put those things to use in the coming examples. Here, let me clean this up. Okay, with the loops, when we are trying to play with the loops, I want the numbers. Okay, let's say this loop is an infinite loop. Okay, and I would say while true, do done echo something or some number. Let's say count equals to 1, echo dollar count, right? And then increment the count, say let count equals to count plus 1. Cool. So that's an infinite loop actually. If I want to break it at some point, so you are already aware of break and continue statements, right? So break statement would be breaking the loop, you would be getting out of it. Continue statement would be skipping the current iteration and moving you to the next iteration in the very beginning of the loop. All right. So if I want to break this loop, so we would say if I want to break the loop at 10, so I would say if my count minus eq 10. Okay, so if the count is equals to 10, in that case, of course, then reverse if it equals to 10, then break off. Let's execute it. Just 1 to 9. Minus gt10 would give you 10 numbers, right? But if I want the numbers just from 7 to 10, I don't want the first 6 numbers. In that case, I would be using continue, right? I don't want to echo the count or simply write a condition like this, that okay, let's do one thing. We'll have to restructure it. If count is less than 7, okay, so if count is less than 7, in that case continue, and we increment the counter here, which is let count equals to count plus 1. Alright, and at the last we would be echoing the count. I hope it's correctly structured, so let's check. Yep, there's 7 to 11 this time. We'll have to make sure it works properly. So I would say EQ10, in that case break, that's fine. So numbers are from 7 to 10, but if you see the loop, it's actually an infinite loop. It's all controlled based on continue and break statements. If you happen to remove break statement, then it would convert into an infinite loop, which we don't want. We have seen functions, right? But we haven't got a clue how to return values from functions. Now this is very new thing in Bash, that how to return values in functions. You would be returning values using actually it is stored in stack, so you would be using it using dollar question mark sign. Okay, let me show you how. We have a function. I would call that function as the modify function or increment function. Alright, so this increment function would be incrementing anything that you pass to it, but we don't know how to pass the values. So start the function body. Whatever I receive here, I told you already that the functions and the scripts would be receiving the parameters as dollar signs. So $1 is the first parameter, $2 is the second parameter, and so on. So in this function, my numbers would be coming in as the first parameter. So I would say my number equals to $1. I want to increment it. So we would be incrementing that. We would say let num equals to num plus 1, and then return num. Return keyword is familiar, right? Everyone knows that. So return is used for returning the values from within the function outside. That's fine, but how do I call this function and get the values out of it? Increment, the function name. Okay, you don't have to support it with parentheses. If you want to pass any of the parameters to it, you could simply write the parameter like this. Now, how do I get the parameter back? Sorry, or how do I get the returned value here in some of the variables? So I cannot write something like this. Var equals to increment 4 does not work. So how do we do it? Dollar question mark retains the last return value of any of the function. Okay, the last return value. So if I run this function twice, okay, so dollar question mark would be holding value 7. That means 6 plus 1 is 7. It will not be holding 4 plus 1. Alright, so make sure that when you want the return types from both the function calls, you handle the returns just after the function. So here we would be returning it. So I would say value return equals to dollar question mark, and then echo the return value. Okay, so let's try. Uh, Let me set the numbers. Yeah, it's dollar num. Sorry for that. There it goes. So it is 5. If I happen to change it, increment something else, so it would give me 7. We can make it dynamic. So my increment should be taking the value from standard input. Now this $1 and the $1 inside a function is different. So we would say example 50 or 45, it would give us 46, 47 would give us 48, and so on. Okay, so what we did now is to pass a parameter to this function which was handled in a global space. When you pass parameters inside a function, in that case those parameters would automatically be handled in a local space, unlike any other variable, because in case of variables you will have to specify that the particular variable is local inside the function, and we have seen that already. The keyword is called local keyword, which helps us to limit the scope of the variable to the functions. Otherwise, it would be available in the public space. If you want to present menus to your users, menus as an you might have seen in few of the commands, it asks you to type a particular character. Type 1 for this, type 2 for that, type 3 for something else. Okay, so you could easily create it. This kind of loop here in Bash is called select loop, and they have provided that to create nice interactive menus for the users. Uh, the keyword is select. So select word in whatever words or sentences you want to present. So you would say select word in, say, echo. First, what is your operating system name? Okay, select word in Ubuntu. Again, this is a white space array, so separated by white spaces. It says, okay, word in Ubuntu, CentOS, RHEL, Mint, and so on. The loop starts with do, ends with done. Okay, then we would write you selected what? Dollar word. This word comes in from uh, the word variable that we define on the second line. So select any variable name. That variable name would be available inside the loop. Make sure you break out of this loop, otherwise it would loop endlessly. Let's try it out. Example, there it goes. So it says, what is your operating system name? You select one of these, 1 2 3 4. I selected 5, so 5 does not exist. Okay, so what you could do is you could make this statement here as uh, conditional. Okay, so let's try it out. If minus z word, right, then break 5. A word does not exist, right? So should have worked. Minus n s1, when the string is not empty, break, otherwise do not break. let me check one more thing here, that instead of this we would be using something else. Since the string is a null string, the length of string would work, right? So if my string size is more than 0, so I would say 0 is less than the size of string. So we could write size of string to be like this. Then break, give it a shot. Right. So now it works. If you type in something else, it makes you um, reselect the things. Okay, if I try it correctly, it says it's okay. Nice. So you could also add else statement to this so that it is more elegant. You selected $word. There you go. So I would just echo, please enter a correct selection, and you selected $word. Okay, so let's try it again. It should look nice. What is your operating system name? I say 7. It says you selected nothing. Okay, 5, nothing, 3. Okay, I messed it up. It should be here. Logically, you selected $word should be at this location, and it should be here. Right, that's when I break off. Great. Now it looks nice. So what is your operating system name? 1234. Type in anything that matches. If you type something that doesn't match that particular list, in that case it would say please enter a correct selection, and else it breaks off. Okay, so that was a selector loop or select statement. Another one is also present here, which is called your case statement. Okay, so let's see how case statement would work. Vim example, selector statement is off. Now the case statement. So in case statement, you'd be writing your um, indexes all by yourself. Otherwise, let's say you want to create the same menu example here. So what you'd be doing is the similar things like enter your or choose your operating system. And then you give the selection to the users. So say one for, so you'll have to handle all of these things all by yourself. Or even in programs where you don't want to create a menu. So this is just an example that I want to create a menu here. So I would say one for Ubuntu, two for CentOS, and so on. Then we get the input from the user by using read, right? In a variable called case. Then, or let's say write it option. Then we write case. This is the beginning of your switch case. Case option in. Now the options have to be presented by the option value and a parenthesis. Let's say echo It's all up to you how to handle this. Option number 2. Between two options, there should be a break statement, but break statements here are not explicit. You'll have to mention double semicolons to break the line. Echo, you selected CentOS. That's how it would work. Say ESAC, which is reverse case ESAC. Double semicolons are important to break between the two options. Options are starting with the option value and a parenthesis, a closing parenthesis. Let's run it. It says enter your operating system name. I would say 2. It says you selected CentOS. Okay, very simple example here. You could convert that into an interactive loop using infinite looping in while. Okay, that would also work. But if you want to go for menus, go with the selector statements. They are more easy to implement and you have to code less. Okay, let me remember what is supposed to be covered next. It is the string types. So I was talking about the strings. Let's say we have a string called alpha and we have a variable called 123. Okay, so if I want to echo something out here, instead of string, let's echo it. Echo the number is $123. We have been using this for long, right? $var, and we know that it works. But if I convert the string from double quotes to single quotes, now it does not resolve. Okay, so single quote strings do not resolve the variable names. If you want the variable names to be resolved, you will have to add it in double quotes. What about the escape characters? Escape characters like new line character or a return carriage or space, backslashes and all those things, you could mention them in echo statement by placing a minus e. Okay, so we would be adding a tab in between. So let's check it. Now you get tabs. What if I don't place minus e? You wouldn't escape those characters. Minus t are seen here on screen as it is. Okay, so that's completely up to you whether you want to escape it or not. It does not depend on what kind of string you use. You'll have to mention specifically that you want to escape it using the echo statement. Again, double quotes are used for explicitly uh, resolving your variable names to the values. If you use single quoted strings, in that case you will not be able to do so. So here there are multiple escape characters. We have seen backslash t. So backslash t is used for horizontal tabs. Then there is backslash a for alert. So it gives a bell-like sound. Then there is backslash e is just an escape character, a white space character. Backslash n, you are all aware of it. New line character. Double slashes is the backslash. Okay. Then minus b is backspace. R is carriage return. Then backslash v is vertical tab. Remember that once you do vertical tab, you will not be able to move upwards. Backslash single quote is single quote. Similarly, backslash double quote would be a double quote. If you want to place any octal value of characters from ASCII table, let's say you know what the value of A is, it is 64 or 65, I guess. So if you want to mention that in octals, you could place that like this. All the octal numbers, so it would be backslash an octal number, so starting with 0 and whatever your octal value is. For hexadecimals, you'd be using backslash x and numbers. Okay, hexadecimal number starts with x. Let me show you one. So I would say echo backslash 40 x40 is a value for ampersand. Again, do escape it. We'll see what the output is. Okay, so it doesn't show me backslash 40 x40, it shows me ampersand. So backslash x40 was then converted to the ASCII representation of it, the character wise representation of it. For octals, there is one octal example that I'm aware of, which is minus E. It is 56. Octal 56 is octal for dot. Oops, it messed up. Yeah. So octal starts with 0 and dot is a octal for dot. That's what it is representing. But actually we have written slash 056. So what we're trying to do here is algebraic operations. So algebraic operations, we have already seen a few types of algebraic operations like One of the way is dollar parenthesis, another one is double parenthesis, yet one is let keyword. So I would be using all of these here, and we'll see how does it make sense. First way is to write let keyword. So let res equals to dollar $x plus dollar $y. Echo dollar $res would give me the result there. That's one way. Okay. Another way is to write res equals to dollar $1 plus dollar $2. Okay. In this case, you wouldn't get any algebraic operation rather, but you would be getting concatenated string. So you would be echoing dollar $res. It's all messed. Sorry, dollar $1 does not exist. My fault. It's dollar $x and dollar $y. Okay. Another way. When you write res equals to dollar and double parenthesis, then dollar $x plus dollar $y, and then echo dollar $res should give you the answer, because using the dollar sign with parenthesis would execute your commands. Okay, so you could use any one of these that specifies your requirement. All right. Um, Yet another one would be to declare the result as integer directly instead of string. So I would say declare minus I for integer res, and then we do res equals to dollar $x plus dollar $y, then try to print it, echo dollar $res. Now this time it should give us the answer instead of 10 plus 5. So you would be using any one of these methods that that suits your requirements. In general, arithmetics would be simply replacing plus by any other operator. Okay, you can also do um, output formatting here with bash. So output formatting is writing $f, writing $d for formatting your strings. Okay, so let's see how do we do that. Printf statements work here. So I could write something like this: dollar printf. Okay, and printf whatever you want to do. Let's in my case %d or %5d rather. It's hello, it's %5s. Okay. Oops, sorry, it's -s. It should be -f for float numbers. There it is. So if you convert this number into a float and then write that I don't want any decimals to be present, or just 3 decimals to be present, it would give the answers according to that. So -3 or just 2. In this case, you'd be having 2 decimals. If you want to tab it to left or right, so minus sign would work, but it would work along with other columns. See, if other columns are not present, in that case you will not be able to do left or right indentation. It would be always indented to the left. So coming to the last part here of bash, which is the pipes, okay, or file descriptors. So by default there are three file descriptors which are present on the system. So one of them is called standard input, stdin, and the number for that is 0. Another one is std out, the number for that is 1. Yet another is std err, standard error, the number for that is 2. So there would be three files present on this system by default. uh, Actually these are not physical files, they are in-memory files. They are also called as pipes. Pipes are generally used for high performance read and write operations, from where you would be sharing the data. Okay, so if you're writing to standard input, all the programs who are willing to pick up their data would be keeping a track on their standard input. So whatever I'm typing here, it would be first written into standard input pipe, and from there the applications would be picking up their own data. So here the standard input is file number 0 or pipe 0, standard output is 1, standard error is 2. So if we write some commands, okay, so ls/abc would give you an error here, whereas ls/var would give you a result. So let's do one thing. I want to redirect this to some file. I want the output to be stored in a file. So for that I'll have to redirect the pipe. Okay, by default when you say a greater than arrow, a greater than sign, it means standard output redirection. So let's see, um, ls or any script for that matters, if the script ends with a return type of non-zero, it's an error. So let's say I exit this with error 1, echo this is an error. Okay, so we're exiting with error state 1. I'm going to execute this. Okay, so that says that this is an error. What is the return type of it? Dollar question mark. It's 1. Okay, so that is going to be error execution. If it is 0, in that case that is going to be a standard execution. That means there is no error. Similarly with the commands like ls/var, the return type is 0. If you do /abc, abc does not exist, so the return type is going to be some number and some message related to that. So if I want to store the output into a file, I would do a redirection of it. So I would say ls/var, all the results should be written to another file. I would call that file as out. The name of the file is out. See that there is a new file out created. You open up the file by, or read the file contents using cat out should show me the results in that particular file. Okay, that's fine. But if I want to do the same thing, ls-var with lsabc, and now check the file, the file is empty. Okay, so the difference here comes from the screen itself. The first time when I typed ls/var and redirected that to out, there was no output seen on the screen. The reason was that the screen that you see is actually a merger of two pipes, standard output and standard error. So whether you get an error or whether you get a standard output, you would be getting those on the screen. But when I redirect that specifically, that redirect the standard output to the out file, that means anything that was present in the standard output now is a part of that file. What about the error? Errors are not. Okay. Next time when we fired the command ls backslash or slash abc and redirect that to out, that means we told that command that if you get a standard output, in that case redirect that to the file. But unfortunately we haven't received any standard output, we received an error. Okay, Just to prove that errors are thrown on different pipe and standard output is thrown on different pipe, this is an example. So here our output was 0, so in the file we don't see any content. We see the error on the screen, of course. But if I want to store only the errors into the error file and not the standard output, that can also be done. So that has to be done like this. I've written 2 in front of the greater than sign. 2 is actually the pipe number. If you don't mention the pipe number, it is always going to be 1. So if I hit this command now, this time I don't get any error on screen like in the previous case. Okay, at the same time, my file is not empty now, it contains the error. But if I fire the same command for /var exists, it will not generate any error, right? So we would see output on the screen and error inside the file. Since there is no error, in that case, the file should be empty, right? So I hope you got the difference between these two. One more thing I want to show is, if you want to store the errors as well as standard output in the same file. Not recommended. We generally use 2 different files for storing error and standard output. But if you want to store both of them in one single file, in that case, you will have to merge both the pipes together. Okay, so in order to merge both the pipes together, you'll do something like this. Your command, whatever your command is, then pipe number 2 should be merged to address of pipe number 1. Okay, so standard error is now a part of standard output. So you could easily merge from, easily redirect from standard output. So ls/var redirected to output. Now you say that the standard error is also a part of standard output. So errors and outputs would be going to the same file called out. Hit the command, check the file. You should be able to see the result there. If I use /abc, in that case, still you don't see anything on the screen. That means it's redirected to the file. But here in this case, the previous results are getting scrubbed off. I want the previous results to be saved. Just in case if I want to use these commands for generating logs or storing logs to another file, in that case I should be able to append to that file and not rewrite it. So here instead of single arrow, you would be using 2 arrows, 2 greater than signs. So these 2 greater than signs would be treated as append operation, not as a write operation. So I have executed this command 5 times. We will check what's there inside the file. The file contains repeated errors. If I execute correct command here, /var, it should contain the output as well. Alright, so double greater than arrows would mean append. Single greater than arrow would mean standard out redirection. If you mention the pipe name, that means the number of pipe, that would consider that pipe for redirection purposes. If you do input redirection, that input redirection is considered using less than arrow instead of a greater than arrow. Okay, and we have seen that input redirection using a loop. Some of the commands would also allow you to do input redirection, but you'll have to check the documentations for such commands. All right, so that's about it. That's one more thing that is supposed to be covered is background execution of the jobs. So bash allows you to run the jobs in the background. So for doing that, let's write a small loop, which is going to be infinite loop in my case. So we'd say while true do done echo $count, let count equals to count plus 1, and count equals to 1. So this code here would be an infinite loop. Okay, save it and execute that. Okay, that's an infinite loop. If I want to run that in the background, I could also do that, but for running that in the background, we'll have to mention ampersand sign uh, after the command execution line. So let me open it up. Since this is taking a lot of CPU, I'll have to make it sleep for a second. Okay, there it is. We executed the command like this, right? It is blocking the console. We are not able to fire any of the commands here, right? So none of the commands can be typed unless and until that /example script finishes its execution. But that script is an infinite script, or it went into infinite loop. Or there might be case that we are running a daemon. We want it to be always up, but we also want the screen on which we are typing the commands to be freed of any of these kind of locking, right? For that to happen, I don't want to kill my script even. Okay, so for that to happen, we would be running the script like this: /example and ampersand. As soon as I add ampersand, it would be executed in the background. Okay, now my screen is free from the clutter. I could type the commands, but if you see that the results are still coming up, so what we do is we switch the console, okay, or redirect the output to some uh, external file. For doing that, let me show you how. Either we redirect output to the log file so that we should be able to get the logs, or we redirect the output to a file called dev null. So in this file, it's again a pipe, but it does not write anything to disk. Anything you write to it is lost. Okay, so let's see how do we do that. Very first, I need to kill this command here. So let's first find it. Um, psaux sudo su first. Okay, psaux and then grep example. Alright, so example is running here and the PID is 1599, so I would say kill 1599. It got killed, no output on the screen, right? So that says it's terminated. So execute this again, but this time I want it to be redirected to dev null. I don't want to save any of the output. Okay, and run it in the background. Now we wouldn't be getting any of the disturbance on screen. All the output of that execution is now going to a pipe. Okay, but anything that you're writing to it is not recoverable, it's lost. So for that, what we do is we would be getting it back. So for that to happen, I would be redirecting it to another file, and I will call that file as varlog. In varlog, I will be storing the logs of this execution. Varlog example dot txt or dot out or dot log, whatever you want to write. Now it is executing in the background. We will check what's happening to that log file. Open the log file and see the content. Varlog example.log. So there are lines and the lines are incremental. It's writing to that file, right? And every log that is being generated, it has been appended to the file rather than rewritten. How do you check if the program is continuously writing to it, or you want to keep a track of that file? Okay, so in that case, you would be using the command called tail minus f check and check continuously rather. So varlog example.log. So tail minus f would be a command which keeps a track of the changing status of that file, and it would keep on updating the result on the screen. Okay, Similarly, there is a head command which would be checking for the head of the file. That means at the starting of the file. But generally, when we append it to the end of it. So that's why we would be using tel -f command. The code is still executing in the background. If you want to catch it and finish it up, there is a command called fg, which will bring any of the jobs to the foreground again. Okay, so job is now on the foreground and you cannot type anything. It has blocked the console. To send it again to the background, you could first stop it or just pause it. For pausing it, the shortcut key is Control Z. So it says it has been stopped and you see the jobs now. Okay, so if you want to put something in the background, type in BG. If you want to put something in the foreground, type in FG. Now the job is now executing in the background. If you want to bring it again to the foreground, FG again, it's again in the foreground. Again Control Z, it should be stopped. If you type BG, it would again go to the background. That's how you play with the job. Okay. If you want to kill it, easiest way without knowing the job PID, what you could do is simply bring it to foreground like this and press Control C or send a termination signal. The job is lost. How do I check it? PS aux, then grep example does not exist. Okay, so these are the few operations on the processes, the running it in foreground, in background, logging it to the log file, logging it nowhere. All right, killing them using their PIDs or directly using a Control C shortcut key when the process is in the foreground. Okay, so that's all from my side for Bash. If you have any queries or doubts, you could ask me. In the next session, we would be continuing with a new topic. The new topic is going to be about Docker. Okay, so we are going to learn how Docker fits into DevOps ecosystem. So, okay, so it is going to be module 6, and the first topic there is understanding containers with Docker. Then after Docker, we would be tomorrow we would be spending time on Docker itself, and after that, that means day after tomorrow, we would be starting with Nagios. Okay, so I'll see you again in tomorrow's class. If you have any queries or doubts, feel free to ask it. I'm again here for another 5 and 10 minutes. All right, people. In that case, we would be dropping off the call. I'll see you again tomorrow. Have a great day ahead.